Hello everybody, and thanks for joining us for another session of I Get It Live. Today we're going to be learning about model-based definition, or MBD, in SOLIDWORKS. My name is James Keller. I'm an instructional designer and certified SOLIDWORKS subject matter expert here at I Get It. And just as an overview for today's session, I'm going to show you how to use MBD in SOLIDWORKS, expressly showing you how to use some of the DimXpert tools, how to capture and manage 3D views, and then how to publish that product manufacturing information, or PMI, that you've captured into a 3D PDF. What you'll learn today specifically is how to activate and access MBD. So MBD for SOLIDWORKS requires a license, and we'll quickly go through the steps that you'll need to know to make that happen. You'll also learn how to automatically attach dimensions to your model using the Auto Dimension Scheme tool. This tool can be especially helpful if you're less familiar with GD and T. And we'll also show you how to capture some 3D views. And using these 3D views, you'll be able to communicate your PMI in 3 dimensions. And that basically makes it a little bit easier and creates less room for error. So what to expect for today's session is that it is pre-recorded. Due to a licensing oversight, I wasn't able to actually capture this for you live today, but although this is captured in an earlier version of SOLIDWORKS, everything is completely valid for the newer versions of SOLIDWORKS, including 2022 and 2023. So everything that you'll see here, you would see in those newer versions as well. Because this is not a live session today, questions will not be answered after the session, but anything that you put in the form or questions area, I will be sure to answer promptly within a few business days. In addition, this video will be on our YouTube channel, so feel free to go search for it there. And anytime you want, you can just add a question in the YouTube comments as well, or a question area, and I will be sure to answer those as promptly as possible. So, without any delay, let's go ahead and get started.
SOLIDWORKS Model-Based Definition, or MBD, provides users with a method for sharing their model product manufacturing information, or PMI, without having to create 2D drawings. This helps to streamline part production, cut cycle times, and reduce costly errors. MBD integrates seamlessly with SOLIDWORKS to provide an easy-to-use method for capturing and sharing model product manufacturing information. MBD allows you to create 3D model views for use in manufacturing and can produce 3D PDFs and e-drawings files to help reduce common misinterpretations associated with 2D drawings. 3D model views can be rotated, zoomed, and toggled between standard views. This allows the manufacturer to produce a more accurate part, reducing the likelihood of design misinterpretation. In addition to the PMI tools available in the SOLIDWORKS MBD Command Manager, MBD also gives you options for customizing 3D drawing templates, so you can create 3D PDFs that are easy to share and are unique to your company's design standards. MBD doesn't restrict you to 3D views either. It still provides you with the intuitive tools to print 3D and standard drawing views using your model PMI, so you won't have to spend extra time creating multiple annotations if necessary. Note that SOLIDWORKS MBD is not included with standard SOLIDWORKS packages. Contact your reseller or visit SOLIDWORKS.com to receive an MBD license. Once active, both the MBD Command Manager and 3D Views tab will become accessible. SOLIDWORKS MBD provides a variety of DimXpert tools to help you dimension and annotate your 3D models. These tools will work with imported bodies as well, so that you can add PMI to models shared by design collaborators who aren't using SOLIDWORKS. The DimXpert Manager groups and organizes dimensioned features and annotations in this one convenient location. Note that the tree display style can be changed to show features, which is its default state, or annotations. In addition, whenever an item is selected in the DimXpert tree, the corresponding item is highlighted in the graphics area, so you can see how the information is associated with the model. Looking at this first example, you can see a few features have already been defined and are listed in the DimXpert tree. These features are based on the part's geometry and are not driven by the SOLIDWORKS features making up the part. This means that an imported part consisting of the same geometry would display these same DimXpert features as they're added. Now if I want to view both the feature and annotation items in the tree, I can select Show Flat Tree from the right-click menu. This displays the features and the annotations assigned to them, such as datums, surface finishes, and dimensions. Otherwise, I can choose Show Annotation-Based Tree or Show Feature-Based Tree if I'd like to view these items as nested. Additionally, I can rename an item in the tree to help keep things more organized, like renaming this plane to Top Face, for example. Now let's take a look at a few of the more common DimXpert commands before moving on. The first thing I'd like to do is add a location dimension for these two holes. So I'll activate the command and then select the two holes. Note the pop-up options allowing me to choose the type of geometry selected. In this case, the two most likely choices are hole or cylinder. I'll select hole for them both and place the dimension. Looking at the Property Manager, you have the option to align the annotation as you see fit. A long X was automatically selected here, but I can choose Normal to, or select a reference to align the dimension with. Once I accept the dimension, the two holes are added to the tree along with their annotation. I'll go ahead and add a second location dimension to show the vertical hole spacing. Next, I want to add a dimension to call out the hole sizes. So I'll choose the Size Dimension command and select one of the holes. Note that I can dimension each hole individually, or I can select the pattern option from the pop-up to annotate all 4 holes, automatically placing an instance count in the callout. You'll learn more about DimXpert commands as we progress through the course. And if you're unfamiliar with geometric dimensioning and tolerancing in general, feel free to refer to the relevant GD&T courses within I Get It. For now, let's move on to learning how to use the Auto Dimension Scheme command. As you may have noticed, manually defining a model's PMI can take quite a bit of time. As you can see, just adding datums, dimensions, and tolerance definitions to this simple part can take me several minutes to complete. So you can imagine how long it might take to manually define a more complex part. Also, the more complex the model, the more likely I am to make errors when defining its PMI. The SOLIDWORKS DimXpert can automatically create model PMI for you, based on common industry standards such as ASME or ISO. When you want to quickly attach PMI to a model, or lack familiarity with specific dimension and tolerancing requirements, using this tool can be quite helpful. You can activate the tool from the DimXpert Manager, or from the MBD Command Manager. I'll go ahead and delete the PMI I've manually attached to this model, and then activate the command. The first settings I need to define are for the part type, in this case, prismatic. The type of tolerance applied, I'll go with geometric for this example, and the dimensioning layout for patterns. I'll use linear in this case because I'm not dealing with any circular patterns. The next section is where you'll define the model datums. These are the references that each feature will be dimensioned from, and are what defines the 6 degrees of freedom possible for a 3-dimensional part. I'll choose the top face for the first datum, and click the right mouse button to quickly jump to the second datum selection. I'll choose the front face for that selection, right-click again, and select this right face for the tertiary datum. The scope is the last section I need to define. I can toggle all features to have SOLIDWORKS look for and define all the features in the feature filters list, and I can also refine the definition by checking or unchecking certain features in the list. Toggling selected features lets me select specific features in the graphics area to define, like this hole pattern. I want to define all features in this example, so I'll select the option and click OK to attach the PMI. As you can see, all the annotations required to fully define the model have been attached and use a consistent scheme. In addition, note how all the model features display in green. This is because the Show Tolerance Status tool was automatically activated to let me know which features in the model still need to be defined. In this case, everything has been defined. But if I delete the notch feature from the tree and activate the tool, you can see the notch is now the color of the model, indicating that information still needs to be added to fully define it. And if I expand the hole pattern feature and say, suppress the position portion of the annotation, The geometry displays in yellow to let me know the feature is partially defined. If any geometry is overdefined, it displays in red. I'll go ahead and toggle Show Tolerance Status off to continue. Now before moving on, I want to show you a bit about how these dimensions were created and how they reference the part datums. Datum A is associated with a flatness tolerance on the top face. Datum B is associated with a perpendicularity condition for the front face, and datum C is associated with another perpendicularity condition for the side face. The hierarchy of these datums are also represented in their geometric reference frames. So as you can see, datum B references datum A, and datum C references both datums A and B. The intelligence built into the Auto Dimension tool ensures these types of hierarchies are strictly followed, limiting the likelihood of errors. Lastly, I want to insert a few basic dimensions to better define the part's hole locations. I can do this automatically by right-clicking a position annotation in the tree, in this case for the hole pattern, and selecting Recreate Basic Dim. Dimensions representing the ideal location for the holes are then attached, and detail both the hole instances and positioning in relation to the model datums. And just as with any other annotation, selecting them highlights the geometry they're attached to, which are the hole axes in this case. This behavior will extend into any published eDrawings file or 3D PDFs, so you can be sure that manufacturers have a clear understanding of how the part should be made. Turned parts can be easily dimensioned using the Auto Dimension Scheme tool as well. In this example, I'm going to choose the Turned option and go with a geometric tolerance scheme. I'm also going to choose the Polar Patterning option to dimension the holes in the collar. In this case, I only need to define 2 datums because the part is symmetrical about the z-axis. If there were a key feature or something else to make the part less symmetrical, I'd have to use a 3rd datum to fully define it. I want to define all possible features for the part, so I'll leave this option checked as well. Once I click OK, the part is dimensioned using the scheme I selected. And the Show Tolerance tool confirms that all surfaces and features are fully defined. I'll go ahead and deselect this tool to continue. Now even though these dimensions correctly define the model, I still want to make some changes to the callouts to make things a bit more clear. In this case, I'm going to redefine the leader types rather than just assigning them to different annotation views. So I'll start by selecting one of the linear dimensions, and from the Leaders tab in the Property Manager, select the diameter style instead. I'll go ahead and redefine the style to use an arrow as well. I need to make this change to a few other dimensions too, so I'll jump forward a bit to show the changes. Note that making these changes automatically move the annotations to a more appropriate view, but I still need to move a few more from the front view to the back view to optimize their display. This can be done simply by selecting the annotation and pressing the tilde key to assign the annotation to a new view. I'll go ahead and reassign datum A to the front view as well, and clean things up a bit to finish. Next, I want to show you how to change the display type for individual annotations. In this case, I'm going to change the diameter dimensions to display as symmetric rather than bilateral. To do so, I'll access the document properties, and under DimXpert, Size Dimension, select Symmetric for diameter annotations. I'll have to delete and redefine the annotations for the change to take effect. And make the same changes I made in the prior example to get the dimensions displayed as clearly as possible. Now let's take a look at adding PMI to a prismatic part using a plus and minus tolerance type. Using an updated version of the base plate model, I'll activate Auto Dimension Scheme, selecting prismatic, plus and minus, and linear for the settings. This tolerance type locates the features with linear plus and minus dimensions. It does not apply dimensions to surface features. I'll choose the same datums as before, but this time go with the Selected Features option, selecting one of the hole faces in the model. Note how SOLIDWORKS recognizes the hole as part of a pattern and automatically selects the remaining holes. Once I click OK, you can see that the holes are not dimensioned in reference to datums, but rather are dimensioned by chain dimensions in the X and Z directions, using the plus and minus values set in Document Properties. I can also choose to add the PMI as baseline dimensions, deleting the existing PMI, and then accessing document properties to change the dimension method from chain to baseline. And using the same settings as before, you can see the holes are now dimensioned in reference to the same edge feature. The product manufacturing information added to a model in SOLIDWORKS must be assigned to various annotation views for them to be displayed. These views correspond to the 6 standard views in SOLIDWORKS: front, back, top, bottom, left, and right. When callouts and dimensions are added to a model, they are displayed using one or more of these views. Angled and custom views can be used as well. A model can be oriented to one of these views to show only the PMI associated with that view, and PMI can be moved from one view to another. You can also view all the PMI attached to a model by viewing it at an angle, such as a trimetric view. In this lesson, I'll use this casting example to show you the different annotation views available, as well as how to activate and orient views, and how to use the dynamic annotation view command. I'll also show you how to add new annotation views and assign PMI from one view to another view. Additionally, we'll take a look at a convenient way to arrange PMI for all populated views at once to display annotations clearly as they would in a drawing. As you can see, there are several annotations in this example, all of which are attached to either the top, front, right, or bottom annotation views. Even with a simple part like this, it can be hard to tell which callouts are assigned to which view when viewing it at an angle. Now I can always hide or show a view from the DimXpert tree to simplify the display, but probably the most direct way to view a set of annotations is to activate and reorient to a specific view. This is done by right-clicking a view and selecting Activate and Reorient. This displays all the PMI attached to that view while hiding the PMI attached to other views. Another way you can distinguish what PMI is attached to which view is by using the Dynamic Annotation Views command. When I activate the command from the MBD command manager, you can see that all the annotations disappear. But when I begin to rotate the model, the annotations display shaded, until I rotate the part close to an annotation view with attached PMI. When I do, the PMI displays clearly. And when I release the mouse, the associated PMI stays active. This can be especially helpful when a model contains a lot of overlapping annotations. Simply toggle the button in the command manager to deactivate the tool. If I want to create a new annotation view, I can do so by right-clicking the Annotations folder and selecting Insert Annotation View. I can select the face on the model to make the view normal to, or I can select from a list of orientations to create the view normal to. If I choose Isometric, for example, and then click OK, I'd have a new view available normal to the isometric view. But if I continue by clicking the next arrow in the Property Manager and rotate the model a bit to see the existing PMI, I can select a callout to move to my new view. After confirming the change, you can see that this datum callout is now assigned to the new isometric related view. Now having this datum callout in an isometric view doesn't make a whole lot of sense in this case. It'd be best if it were attached to the top annotation view. So to move it from this view to the top view, I could simply select the callout, press the tilde key on my keyboard, and then select the top view from the list. And there you have it. The datum is now attached to the top view. I'll go ahead and just delete this empty isometric view to continue. Now there are still a few dimensions and callouts I'd like to move around to better display this model's PMI. One of the best ways to accomplish this is by displaying the model in multiple viewports while reorganizing your annotations. This is done by accessing the Window menu and selecting Viewport, For View. By default, front, left, top, and trimetric views are displayed. But since the left annotation view doesn't have any annotations associated with it, I'll go ahead and activate and reorient that viewport to the right view. Now I can see all my annotation views at once, making it easier to ensure I've got each view looking how I'd like it to. Starting with the front view, I'll clean up things a bit, ensuring that each dimension is easy to read. Next, I'll do the same for the top view, moving the B datum to the front view and the C datum to the right view, where they more accurately depict the model. I'm also going to attach this hole pattern callout to the lower left hole instance, dragging the leader arrow to that hole. Then I'm going to move the single annotation attached to the bottom view to the top view. Note that you may need to rebuild the model whenever an annotation is moved for it to display predictably. Now I can feel confident that if these annotation views are exported into a drawing, they will be easy to interpret. "3D views are used to capture a model's PMI and display it clearly for manufacturers and other design collaborators. They can be used to show a model in different configurations or display states, and show how a model's components fit together in an assembly. 3D views are dynamic, meaning they can be moved, rotated, and zoomed in and out on, so it can be easier to communicate details that might be lost in drawings, or when certain details are hidden. Looking at this bracket example, you can see that I've already captured a few 3D views, which can be accessed from the 3D Views tab at the bottom of the window. When I double-click one, the model snaps to that view and displays the PMI I've attached to it. Note that I can still zoom and rotate the model within the active 3D view. And when I do so, only the PMI attached to the view remains visible. This works the same for all the views I've created. I'll go ahead and delete these views real quick by window selecting their thumbnails in the 3D View pane, right-clicking, and selecting Delete. It's fairly simple to create 3D views. Just position the model in the graphics area and click the Capture 3D View button. Once you do, Property Manager options let you further define things by assigning a view name. I'll enter isometric for this one, the configuration and display state you'd like to show, as well as the annotation views you'd like displayed. Clicking OK adds the new view to the Captured Views pane. I'll go ahead and capture a few more so you can see how it's done. In these cases, I'll simply activate and reorient to the annotation views I want captured for each one, ensuring that only the annotations belonging to that view are included. Once I've captured all the views I'm looking for, I'll choose a custom sort order, dragging each view in the pane to reorder things a bit. Now let's say I want to update this isometric view, but I don't want to have to delete the view and then recreate it. I can just right-click on the view and select Recapture View to edit it. After I click OK, any changes are applied. Let's switch over to a caster wheel model to illustrate a few more 3D view options. Now I've already created a few views here, but I'd like to add a few more. I'll start by rotating the model to a position that shows both sets of annotations, and create a new view named Angled View, ensuring both annotation views are included. I'd also like to add another dimension to this view, so I'll activate the Size Dimension tool and attach the additional PMI. Making sure it's attached to the right annotation view. Now rather than having to recreate all my 3D views to include the new callout, I can simply click the Update Previews button to include the new dimension in any associated 3D view. Next, I need to capture a few views showing the various options this wheel comes in. So while keeping my angled view oriented, I'll capture a new view, naming it Small Wheel. Then from the Configurations drop-down, select the Small Wheel config to apply it using the same orientation. Now I can quickly jump between the two view options by double-clicking the relevant 3D view. I want to show a third option next, so I'll hide all my annotations and reposition the model. This time I'll create a new 3D view named Polyurethane and select the relevant configuration from the drop-down. It doesn't really matter what annotation views I include because they're all going to be hidden anyway. Once I click OK, you can see the new view is listed. Now I also want to detail how the polyurethane is molded to the wheel using a section view, but first I'll create another configuration named Section View. Note that it's good practice to create separate configurations for section views or views with visible sketch geometry, because these items can display in unassociated views once published to a 3D PDF or eDrawings file. I'll go ahead and activate the Section View command to show the wheel's cross-section and capture another 3D view, naming it Section AA. Now I can continue adding views to further define this model. But for now, let's just move on and take a look at a few more 3D view options using an assembly model. In the prior lesson, you learned various ways to capture and display model PMI using 3D views. In this lesson, we'll take a look at capturing sectioned views, display states, and even explodes in a 3D view. To start, I want to capture a zonal section view for this assembly to better show how its components fit together. And in this case, I've already created and saved the section view I want to use. I can apply it simply by pressing the space key and selecting the save view. Then I'll capture the 3D view, naming it Zonal Section BB. Now as you can see, I have a few different display states defined for this model as well: default and hidden bracket. For my default 3D view, I'll rotate the model to a position I like and capture the new 3D view. As you can see, no matter how I change the view, I can always return to it simply by double-clicking the view thumbnail. Next, I want to add a view showing my other display state. In this case, there's no need to activate the display state beforehand because I can do so within the 3D view properties. So I'll name the new view Hidden Bracket and then choose the relevant display state from the dropdown. And there you have it. To finish, I'm going to add a 3D view showing the model in an exploded state along with the BOM and balloon callouts. So I'll activate and reorient to my BOM and callouts annotation, which I've based on a trimetric orientation. And when I capture the new view, I just have to select the explode configuration already present in the model, name the 3D view, and do any final adjustments before clicking OK. Now that I've captured all the views I'm looking for, I'll go ahead and do a little custom reordering in the Views pane to wrap things up. And remember, each one of these 3D views can be rotated, zoomed, or moved from their original display, which is what makes using 3D views to communicate your design so powerful. In the next lesson, you'll learn how to select and customize the 3D templates you'll use to communicate your designs in MBD. .3D PDFs communicate your model PMI to design collaborators, much like you would in a 2D drawing. By customizing 3D PDF templates to meet your specific design requirements, you can highlight aspects such as detailed manufacturing instructions, unique assembly processes, and specialized notes, to name a few. To customize your 3D templates, launch the 3D PDF template editor from the MBD command manager. Let's take a look at this default template to start. The large gear icon represents the main model display, where you can view any one of the captured 3D views associated with the model. The smaller gears represent the thumbnail images of captured views. Both can be resized or repositioned to meet your needs. You can even change the thumbnail images or their backgrounds if you'd like. The logo in the upper corner can be changed to your company's logo as well, and quick tools allow you to view it at 100%, lock the image proportions so it doesn't accidentally get stretched, or simply delete it. The note fields to the right of the logo display much of your model's information automatically. A link to model information keeps you from having to enter data manually and reduces the chance of errors. Looking at part number and comments, we can see that these are simply labels. But when I select a custom property placeholder, you can see that it's been predefined to display the model's part number. If I close the template editor and return to my model in SOLIDWORKS, I can access its custom properties and define a part number property in the field. Now this value will automatically populate in the 3D template. You can link any number of properties to a template using this method. Moving over to the Notes placeholder on the right, you can see that this is a PDF form field, meaning that it can be edited in the published 3D PDF by anyone wanting to comment on the design at any time, allowing for details to be added as needed. Since this is an assembly template, we can also see a Bill of Materials table area, where any attached BOM would display. This isn't an editable field, but it can be deleted if it's not needed, just like any other template field. I'll go ahead and continue editing this template so you can see how it's done. First off, I'd like to have some fun and update the template's background image, which I can do from the menu bar. Now since I want this to be a part template, I'll go ahead and expand the note area placeholder because there's no longer a BOM field to consider. Then I'll update the logo image and ensure its proportions are locked before resizing it a bit. I also want this template to be fairly simple, so I'll delete some of the fields in the upper notes area by Control-selecting them and pressing Delete on my keyboard. I'll reorganize the remaining notes as needed. Then rename and resize this custom property field as well, changing it from a part number value to a description. I also want to ensure all of these fields are linked to custom properties, including the Designed By field. So I'll change its text area placeholder to a custom property field type and ensure Designer is typed into the custom property specification. I'll make a few last-minute adjustments to finish, and then save the template to a new location, naming it IGI Simple Part. Jumping over to my model, I'll check to ensure its custom properties match the template fields I created. And if I activate the Publish to 3D PDF tool, you can see my new custom template located in the list of theme options. In the next lesson, we'll continue by publishing a few 3D PDFs. When possible, using native SOLIDWORKS files is always the best way to communicate a model's design. But when collaborators don't have access to SOLIDWORKS, or even CAD-neutral solutions, publishing to a 3D PDF or eDrawings file can be extremely helpful. These formats are widely adopted, are lightweight, and can be opened without having to invest in specialized software. By publishing a part or assembly to a 3D PDF, all of your model's geometry and PMI can be communicated clearly. The best part being that your model can be manipulated in 3D space, greatly improving clarity of design over 2D drawings. In this lesson, we'll look at publishing both part and assembly models to a 3D PDF. Then look at some of the options you can use to interrogate a model when viewing a 3D PDF. Looking at our wheel example, you can see that I've already attached some model PMI, and have captured several 3D views as well. I've also defined all the custom properties I want linked out to the PDF. So this model is ready to publish. I can activate the Publish to 3D PDF tool from the Command Manager or from the 3D Views pane. The first thing I want to do is select the theme for my PDF. I'll go with the custom part template I created earlier. And if none of these templates happen to meet my needs, I could always activate the 3D PDF template editor from here as well. Next, I need to decide if I want to include any primary views in addition to my captured views. I'll go with a top view, a right view, and an isometric view. Now I'll need to define the captured 3D views to include. I'll go ahead and select all in this case, and hold the Control key while clicking the current model option to deselect it. Additional options let me define model accuracy, attach files to the PDF, and even create an accompanying step file, which is a CAD-neutral format. I'll click the next arrow for now, and then click Edit to bring up a list of all the note fields associated with the template, which I can update if desired. I'll keep everything as defined for now, and click OK to publish the document. I'll choose a location to publish to, and also check View PDF after saving to automatically open it. Once open, I can select any of the thumbnails to view them in the main viewport. I can click and drag to rotate, hold Shift to zoom, or hold Alt to pan a view as needed. Note how PMI annotations do not mirror when a view is rotated more than 180 degrees, as it does in SOLIDWORKS. Remember that it's important to capture your 3D views with this in mind. The toolbar above the main viewport gives me several viewing options as well. I can activate a cross-section of a view, change the view's lighting, and even change the model display style. I can choose to view the model in perspective or orthogonally. And if I toggle the model tree display, you can access much of the information captured in the 3D PDF, including any configurations and 3D PMI. Any of these items can be hidden or shown via their check marks. And all 3D views can be activated from the tree as well. And remember the notes section I included in this template? I can simply click in the field to add a note on the fly. And as long as I save the PDF before closing it, the note will remain for the next person who views the file. Switching over to the related assembly in SOLIDWORKS, you can see that I have already created several views detailing how the components fit together, as well as their associated BOM data. With the default view active, I'll go ahead and launch the Publish to 3D PDF tool. Then I'll select a custom assembly template I've already made, similar to the part template you saw me make in the prior lesson, and pick the top, front, and right views to include, as well as my captured 3D views. When I click Next, I'm presented with BOM options because this template includes a BOM placeholder. Note the Exclude from Annotation View checkbox. I'll go ahead and check this because I don't need to display the BOM in my exploded view if it's already part of the template. And when I edit the output text fields, you can see that I'll need to define the material property as well as text for the comments note before moving on. I'll click OK to create the 3D PDF, and as you can see, all the defined views have been populated, and that the BOM has been removed from the BOM and Callouts view. Again, this is okay because the BOM is now listed in the template field. And if I zoom in on the view a bit to see it more clearly, note how the model cross-highlights and ghosts unselected components when I select an item in the BOM. Conversely, when I select a component in the view, the BOM listing highlights. This can be especially helpful for large assemblies, allowing you to easily locate components that might be hard to find in a standard drawing exploded view. And since I can also rotate the exploded view, I can better see how the components fit together, limiting the chance of assembly errors. Another cool feature of 3D PDFs is the ability to measure certain aspects of the model. This allows the manufacturer to reference measurements on a completed project against its digital file. Let's say I wanted to measure the distance between the two main brackets. I could switch to a relevant view and activate the 3D Measure tool from the toolbar dropdown. A pop-up appears letting me know how to manipulate the model while the tool is active. Once I click OK, a toolbar appears letting me choose different snaps and measurement types. Since I want to measure between two faces, I'll toggle the Snap to Planar Faces option, as well as the Perpendicular Measurement option. Then I can just select the two bracket faces to place the dimension. Pressing Escape on my keyboard exits the Measure tool. Now let's say I wanted to measure the angle of this little chamfer on one of the brackets. The model display is currently a bit small to do this easily, but I can enter full screen mode by right-clicking the viewport and selecting Full Screen Multimedia. Now the model display is in full screen and is big enough for me to make the selections I want. To activate the Measure tool this time, I'll right-click and select it from the menu options. And when I'm ready, simply press Escape on my keyboard to go back to a normal view.
Well, all right. Hopefully that wasn't too much for you guys today and you learned a bunch. Just wanted to let you know that you can learn even more if you wanted to go take the SOLIDWORKS, MBD, and DimXpert course in I Get It. Some of the things that you can learn there that you haven't today are specialized PMI techniques, including how to attach PMI to mold cavities, specifically drafted faces, sheet metal parts, and structural members or weldments. You can also learn how to publish to e-drawings. So in addition to the 3D PDFs that we saw today, you'll learn how to publish to an e-drawing file as well. And probably the most valuable aspect of the course is that you'll be able to practice and assess as you go along. So the course includes step-by-step workshops to let you practice all the things that you've learned today and more on a different model example than you've seen. And you get to affirm what you've learned as you move through each unit with quizzes. So it'll kind of test and reaffirm the lessons that you learn in the course. Well, with that, I just want to thank everybody again for coming and looking forward to seeing you at the next live session.